Hello, I'm Dinesh Rohan. Today I'm going to show you piezoelectric experiment circuit connection. Let's. So this is input signal channel 1 pin, which I am connecting with breadboard, and through breadboard I am connecting piezoelectric sensor with this input signal. So I can receive signal from a signal generator, and I and so that piezoelectric sensor can vibrate. Now I am connecting channel 1 of oscilloscope with breadboard to connect it with to get signals from piezoelectric sensor. So basically, channel 1 of oscilloscope will show us input signals. Now I am connecting another terminal of piezoelectric sensor with breadboard, and now I will connect channel 2 of oscilloscope with breadboard. So through breadboard it will be connected to the terminal of the piezoelectric sensor to get the desired output. So now channel 2 of oscilloscope is connected with another terminal of piezoelectric sensor, and now we can see I have set the frequency to 1 kilohertz, and through channel 2 we can get the output on the oscilloscope. Now you can see I am increasing the frequency in signal generator, and we can see the change in the oscilloscope. And now I am scaling it so that we can see it perfectly. Thank you.
Hello, I'm Aryan, and today I will show you the circuit of a photodiode experiment. We will take LED and we will insert it on breadboard. With which in series we will connect the 330 ohm resistor. Now we will take breadboard module, and of which the 5 volt 5 volt source we will connect with LED, and other one we will put it on the other side of the breadboard, which is the ground line. Now we will take input signal. We will connect a positive terminal of the input signal with LED, and negative with the grounded. Now we will ground the other side of resistor. First circuit is completed and LED has started to glow. Now we will take the photodiode. With which in series we will connect the 10 kilo ohm resistor, and other side of the resistor we will ground it. Now we will connect the channel 1 to the input signal, positive terminal to the positive and negative to the ground. After which we will take channel 2, and of which the positive side of channel 2 we will connect with the photodiode, and negative we will connect with the ground. And that's how our circuit will be is complete. And as you can see, we have given input from signal generator, and we can see the input and output waveform in oscilloscope. The blue one is output signal and the yellow one is input signal. Thank you.
So far, we have shown the circuit setup for both the piezoelectric sensor experiment and the photodiode experiment. We have also plotted the graphs for the first experiment. Now we will move on the analysis part and answer the specific questions for each experiment. Experiment 1, piezoelectric sensor experiment. Let's now talk about the piezoelectric sensor. We already have the magnitude and phase response plots from the experiment, which I am showing on the screen. This is magnitude versus frequency curve, and this is phase versus frequency curve. First, let's focus on the resonant frequencies. In the magnitude versus frequency plot, the resonant frequency is where we see the peak. This is the frequency where the sensor is most sensitive and produces the strongest response. By looking at our graph, we can see that the resonant frequency is around 260 Hz. Next, we calculate the quality factor. The Q factor tells us about how sharp or narrow the resonance is. A high quality factor means the resonance is sharp, and a low quality factor means it is broad. We calculate it by using the formula Q is equals to resonating frequency upon bandwidth. For our quest, a resonant frequency will be around 100 to 200 Hz. Now, and as mentioned in the assignment, we have calculated quality factor for each resonating frequencies. Now we are moving to our second experiment, which was photodiode experiment. Let's first discuss the 3 dB cutoff frequency. In the magnitude response graph of the photodiode, the 3 dB cutoff frequency is where the curve drops down by 3 decibel from its maximum value. From our plot, we can see that the 3 decibel cutoff frequency is around 25 kHz. Now let's summarize our experiment and conclusion. To summarize, we have completed the tasks for both the piezoelectric sensor and the photodiode experiments. For the piezoelectric sensor, we found that the resonating frequencies and calculated the quality factor. For the photodiode, we found the 3 decibel cutoff frequency and analyzed it. That's it for our experiment. We hope this helps in understanding the behavior of piezoelectric sensor and photodiode in response to varying frequency. Thank you.